Bright Tuty. Every student matters.
So the next major development that happened after Newland gave his law of octaves was the development of Mendeleev's periodic table. Dmitry Ivanovich Mendeleev was a Russian chemist. What he did was that he arranged elements on the basis of atomic mass and also on the similarity of their chemical properties. So based on this, he made a new classification system, and that went really well. So before we get into that, let's understand a little bit about the person who gave it. So Mendeleev was born in Siberia in 1834, and his arrangement came to be known as Mendeleev's periodic table. It was one of the most important classification systems at that point of time, and it became a unifying principle in chemistry. So when he gave this system, only 63 elements were known. Of the 118 that we know now, only 63 were known until then. He studied the relationship between atomic mass and their physical and chemical properties. So he correlated atomic mass with chemical properties and with physical properties. For chemical properties, he used the formulas with oxygen and hydrogen. So he studied how the element reacts with oxygen and how it reacts with hydrogen. Now, why did he choose only oxygen and hydrogen? He chose them because they are really reactive and they form compounds with almost most elements. So because they react with so many elements and they have a reactive tendency, he chose them as a basic criteria to study chemical properties of all the elements known then. On arranging the elements, he found that there was a periodic reoccurrence of elements with similar chemical and physical properties. So he was able to see that there's a pattern that is repeating itself. Mendeleev formulated the periodic law, which was stated that the properties of elements are periodic function of their atomic masses. So he said that if you arrange elements on their atomic masses, after a certain time they'll repeat in a periodic fashion because they are a periodic function of their atomic masses. So he arranged them and then he called the columns as groups, like these are the groups in his classification, and the rows were called as periods. So you see that these are the periods, period 1, period 2, period 3, and these are the groups, group 1, group 2, group 3, and so on. Mendeleev had predicted the existence of some elements that had not been discovered at the time. Now, as you studied in the limitations of Newland, when new elements started being discovered, they could not be put in here. And so, it became important to see that where would we put in all these new elements. So Mendeleev made a classification wherein there were gaps where you could put in new elements. So there was a scope for new elements to be put in here. So as you can see here, so this is the Mendeleev's classification. We have 8 groups and we have 6 periods, and the classification has certain gaps. He also gave the formula of oxide and hydride on the top because these were the bases on which he classified. So this entire group had a similar basic formula. This entire group had similar basic formula, and so on. Okay, so that was the classification by Mendeleevs. The major achievements that he demonstrated with his system was that he placed all the known elements in groups and periods. With this kind of classification, he was able to achieve much more than Newland's. In some cases, he placed elements with slightly greater atomic mass before the element with lower atomic mass. I'll show you an example here. So when you see cobalt and nickel, so you see that cobalt has a higher atomic mass, but it is placed before. So it's a slight change. So he made it just to accommodate in such a way that all the elements with similar properties are grouped together. That was his main concern. So sometimes he placed the elements with slightly greater atomic mass before the elements with lower atomic mass so that elements with similar properties could be grouped together. He also left some gaps and predicted that more elements will be discovered later on in future. And that is why you can see gaps like these in the system. Now for the new elements that will be discovered, he used a prefix eka. Eka is a Sanskrit word which means 1. So he called elements like eka boron, which was eventually discovered, that was scandium, eka aluminium, later discovered as gallium, eka silicon, which was again germanium. So he named these elements which were not discovered until then, and he said that they will be discovered. He named them based on the elements around them, And later on, in fact, we did discover these elements and we were able to put them in the classification without disrupting the structure. So that was one of the great achievements of this classification. Another important fact was that noble gases were not discovered up until this point. Why? Because noble gases are inert in nature, so they do not show any reaction, and that is why, and also because they are really the concentration of them in the air is very less, so they are present in a very small amount, and also they do not react. So because of this, we did not know about their existence for a long time. But when we did discover them, we just added a group and put them separately, and there was no problem with the classification system. So it could also accommodate the discovery after the discovery. It could also accommodate the noble gases. But it did have its own limitations, of course. The first limitation was location of hydrogen. Now, hydrogen, as you know, has atomic number 1. So because hydrogen has only one electron, it can either give it or it can also take one electron to get a stable octet, a stable first shell K with 2 electrons. Now it resembles alkali metals as it combines with oxygen, halogen and sulfur because it gives a Waite's electron. But it also resembles halogens. Halogens take one electron. So it can also behave like them and combines with nonmetals and metals to form covalent compounds like they do. It in fact exists in form of diatomic molecule of H2, which is something that a lot of halogens do, like Cl2, Br2, I2. So the halogen group exists in the form of diatomic molecules, and so does hydrogen. So because hydrogen has properties so similar to alkali metals as well as to that of halogens, it was not clear where should this be placed in this classification system. Another problem was of isotopes. So let's revise what are isotopes. Isotopes are different forms of same element which have the different number of neutron. So they have the same atomic number but they have different atomic mass because they have different number of neutrons inside the nucleus. So because the atomic number was changing with different isotopes, it was not sure. So isotopes were not discovered up until this classification came into being. So it was no problem until then. But when isotopes did get discovered, it was a problem because all the isotopes are in fact of the same element and they would have to be put separately if we arrange them based on the atomic masses. So another problem was that after the discovery of isotopes, it was not clear how should they be accommodated in the new system. For example, we have chlorine 35 and chlorine 37. Now they have different atomic masses, so should they be placed separately? And they are both in fact chlorine. So this kind of problem was not resolved by Mendeleevs classification system, and these were a few limitations. But again, even despite these, it was one of the major breakthroughs in classification. Another issue that was with the Mendeleevs classification was the difficulty in predicting undiscovered elements. So we did not know how many more undiscovered elements lie between two elements. Because atomic masses are not, in whole number, we do not know if how many more elements can exist between two elements, if at all. So it was not clear as to what are the different spaces that we have available for new elements, and so we did not know what are the new elements and how will we be able to study them. So atomic masses did not increase in a regular manner, which we know that atomic number does increase in a regular manner. We'll come to that in the next portion. But because this arrangement was based on atomic masses, it was not clearly telling us where would these new elements, how many and where would the new elements